Let's proceed to our first lesson, which is the parts of the mBot. At the end of this lesson, the learner will be able to identify the different parts of the mBot. mBot has two types of parts. The first type is the mechanical parts, and the second type is the electronic parts. Mechanical parts relate to machines or tools and process involves a purely physical force. These include chassis, two pieces of DC motors, a pair of wheels, roller ball, two pairs of velcro, four pieces of brass stud, and screws and nuts. These include 4 pieces of 2x9 top screws, 15 pieces of 4x8 screws, 6 pieces of 3x25 screws, and 8 pieces of nuts. Electronic parts process the flow of electricity and operate through numerous small electrical parts such as microchips and transistors. These include battery holder, ultrasonic sensor, line follower sensor, Bluetooth module, M-core, 2 pieces of RJ25 cables, USB Type-B cable, and IR remote controller. Let's have a quick review about this lesson. Can you name this part? If your answer is ultrasonic sensor, then you are correct. What type of part is shown in the picture? Is it mechanical or electronic part? If your answer is mechanical, then you are correct. Which of the pictures show an image of the DC motors? Is it letter A, B, C, or D? If your answer is letter B, then you are correct. In this lesson, we identified the different parts of the mBot. These include the mechanical and the electronic parts. Now that you know the different parts of the mBot and be familiarized with it, let's proceed to our next lesson, which is the mBot's M-core. At the end of this lesson, the learner will be able to define the M-core and identify the different parts of it. Before we begin the lesson, the learner can already recognize the different parts of the mBot. In our past lesson, I discussed the parts of the mBot. These include the mechanical parts and the electronic parts. M-core is one of the electronic parts of the mBot. Now, let's proceed to our lesson. First things first, what is an M-core? M-core is an easy-to-use main control board specially designed for mBot. Based on Arduino Uno, M-core integrates various onboard digital outputs such as buzzer, light sensor, and RGB LED. M-cores consist of different electronic parts attached to it. The first one is the DC power jack. It is an electrical connector for supplying direct current power, wherein we connect the battery holder. Aside from DC power jack that can supply direct current power, we can also use 2-pin connector for lithium battery. It is typically used for low voltage applications. This is where we connect the lithium battery. Power switch. It turns on and off the M-core. Button. It runs the program when pressed. Reset. A button that allows you to reset the program. Motor ports. They are used to connect DC motors to the M-core. RJ25 ports. They are used to connect RJ25 cables to the M-core. USB Type-B connector. It is used to connect USB Type-B cable to the M core. RGB LED. It is used to show different colors. RGB stands for red, green, and blue, and LED stands for light emitting diode. Buzzer. An electric device that makes a buzzing sound. Light sensor. An electronic device used to detect light. Infrared receiver or IR receiver. It is a hardware that receives data from IR remote control. Infrared emitter or IR emitter. It is used to transmit IR signals from a remote controller. Let's have a quick review about this lesson. It is the mBot's main control board. If your answer is M-core, then you are correct. Can you name this part? If your answer is power switch, then you are correct. Can you name these parts? If your answer is RJ25 ports, then you are correct. In this lesson, we defined the M core and we also identified the different parts of it. In this lesson, we are going to create our first mBot program. At the end of this lesson, the learner will be able to create his first mBot program, define each command block used in the program, and upload the program into the M core. Before we begin the lesson, it is required that the learner must know how to connect the mBot to the mBlock application. In our past lesson, I discussed to you what an mBlock is and how to connect your mBot to the mBlock application. Now, let's proceed to our lesson. First, launch the mBlock application on your desktop and connect your mBot to mBlock. I will not go on the details on how to do it because I've already discussed it in our past lesson. If you don't know how to connect your mBot to mBlock, please watch the previous lesson entitled How to Connect the mBot to mBlock Interface. Let's hide the stage layout in mBlock Interface because we will not create an animation in our program. To do this, go to Menu, click Edit, then Hide Stage Layout. The left side of the screen shows the script panel. This contains 10 modules to program Scratch and mBot. Each module has its unique color to easily identify what module is used by a particular command block. In mBot programming, we only used 4 modules. These are data and blocks, controls, operators, and robots module. Data and blocks are used to make variables and blocks. Control is used to direct actions or behavior of the mBot. Operators are used to write a mathematical function in the program. Robots module are used to control the actions of the electronic devices attached to the M core. Let's create our first mBot program. First, in the robots module, drag and drop the mBot program to the white space area of the screen. This block is used to upload the program into the M core. Then, in the control module, drag and drop the wait until block next to the mBot program block. In the robots module, drag and drop the button pressed block inside the wait until block. This nested block allows you to run the program when the button is pressed on the M core. I'd like to set the RGB LED of my M core to red. To do this, in the same module, drag and drop the set LED next to the wait until block. There are 3 colors available in this block: the red, green, and blue.
These three primary colors can be used together to mix different colors. You can set the value of each color from 0 to 255. 0 means the dimmest light and 255 means the brightest light. I will set this block to red and put a value of 255. This means that the LED will produce the brightest red light. Next, we will put a delay on each block. To do this, drag and drop the wait block from the control module next to the set LED block. You can change the value of waiting time to any value you want, but in our purpose, I will leave the default value of 1 second. Next, I want to copy the set LED and wait block. To do this, right-click the set LED block and click Duplicate. Then drag and drop it next to the wait block. This time, I want to change the color of my LED to green. To do this, set the value of red to 0 and set the value of green to 255. I will do the same procedure to change the color of my LED to blue. The last step is to turn off both my RGB LED. To do this, set the red, green, and blue to 0. Copy the last set LED block and then drop off the last wait block because it will not use in the program. This program will make your mBot turn on his RGB LED to red, green, and blue for every second and turn off the light when you press the button. Now, I will upload this program into my mCore. Right-click on the mBot program, then click Upload to Arduino. On the right side of the screen, you will see the Arduino mode of the program. Click the Upload to Arduino button to start the uploading process. Wait until the uploading process reaches 100%. When the upload is finished, click the Close button. Disconnect the mBot to the mBlock and let's see the program we uploaded to the mCore. Let's have a quick review about this lesson. Which block is used to upload a program into the mCore? If your answer is letter B, then you are correct. Which block is used to put a delay on each block? If your answer is letter A, then you are correct. Which block is used to set both RGB LED to blue? If your answer is letter C, then you are correct. In this lesson, we created our first mBot program, defined each command block used in the program, and also we uploaded the program into the mCore.
Now that you know how to connect your mCore and how to upload an mBlock program, let's proceed to our next lesson, which is the basic movements. At the end of the lesson, the students can create a program and make the robot move forward, backward, and turn. Make the robot move with a specific amount of time, and set the speed of the motors. Before we proceed to this lesson, the student should have already taken the lesson on mBlock programming. The student can open an mBlock software and can connect the mBot to mBlock interface, can upload an mBlock program, and can define the functions of the following blocks. Let's have a quick review of the past lesson. mBot program is used to upload the program to the mCore. Wait 1 second. Allows you to set a specific amount of time. Wait until button is pressed. Runs the program when the button is pressed. Lesson proper. Run forward. Run forward block will make your robot move forward. This block can be found in the robots module. There is a drop-down menu on the Run Forward text that allows you to choose one value from a list. This contains run forward, run backward, turn right, and turn left. You can set the speed of the motors from the drop-down menu of the speed text ranging from -255 to 255. 255 is the maximum speed. 0 is the neutral speed or stop. -255 is the maximum reverse direction speed. Remember, using negative speed reverses the run action of the motors from forward to backward and vice versa. Aside from selecting a value from the drop-down menu of the speed text, you can also type a value in the text field. Note that the value must not be higher than 255 and not lower than -255. Here is the sample program to make your mBot run forward. When the button is pressed, the mBot will run forward at the speed of 100 for 2 seconds and then stop. Here is the output of our sample program. You can try it yourself. Question: I programmed the mBot to move forward, but it's moving in a curved path. How to make the mBot go straight? DC motors are normally not equal in speed. This is the reason why your mBot is not moving straight. To correct that, we need to calibrate your motors. Motor calibration. In this video, the mBot is moving in a curved path, going to the left. The motor on the left, which is M1, is slower than M2. In as much as M2 is faster than M1. To make the mBot go straight, we need to set a faster speed for M1 and a slower speed for M2. To calibrate the motors, we need to break down the run forward block to 2 set motors block. This block can be found in the robots module. Based on the video shown, the mBot is moving curved to the left. It means the left motor or M1 is slower. So in my program, I made the speed of M1 faster than M2. I set M1 to 255 and M2 to 200. Then complete and upload the program. You can try it yourself and test the mBot. Run backward. If you want your mBot to move backward, you can select the run backward from the drop-down menu of your forward text. Here is the sample program to make your mBot run backward. When the button is pressed, the mBot will run backward at the speed of 100 for 2 seconds and then stop. Here is the output of our sample program. You can try it yourself. Turn right. If you want your mBot to turn right, you can select the turn right from the drop-down menu of Run Forward text. Here is the sample program to make your mBot turn right. When the button is pressed, the mBot will turn right at the speed of 100 for 7 seconds and then stop. Here is the output of our sample program. You can try it yourself. Turn left. If you want your mBot to turn left, you can select the turn left from the drop-down menu of Run Forward Text. Here is the sample program to make your mBot turn left. When the button is pressed, the mBot will turn left at the speed of 100 for 7 seconds and then stop. Here is the output of our sample program. You can try it yourself. Let's have a quick review. What is the action of this program? The robot will move backward. What is the action of this program? The robot will move forward. What is the action of this program? What is the action of this program? The robot will move forward. In this lesson, we discussed that using weight will make your robot move for specific amount of time. Using negative speed will reverse the run action of the motors. End of the lesson. Lesson 8. Introduction to Sensor. At the end of the lesson, the students can define what a sensor is, name a device that uses sensor, and differentiate the uses of ultrasonic and line follower sensors. Before we proceed to this lesson, the students can identify the parts of mBot, can assemble a robot with sensors, can program the mBot to move forward, backward, and turn, and can control the speed of motors. Let's have a quick review of the past lesson. To make the robot move, use the Run Forward block. You may click the drop-down menu to select backward or turn movements. Motor speed can be set from 0 to 255. The higher the number, the faster the motor. Using negative speed will reverse the action from forward to backward or vice versa. Make it a habit that when you program an mBot, use the wait until button is pressed block to avoid your motor from moving upon powering on. Use wait block to set a specific amount of time to an action. What is a sensor? Sensor is a device that detects heat, light, motion, color, sound, pressure, distance, and etc. Sensor can make a robot detect the environment and respond to it. Here are some examples of devices, machines, and facilities with sensors. Some of them can be found in malls. The example is the automatic sliding door. It opens and closes automatically once the object inside the range is detected by the sensor. Most of the comfort rooms today are using automatic faucet and hand dryer. They have sensors too. Do you enjoy playing games in amusement parks? Are you wondering how the machines follow your actions? They have sensors that detects motion or light from the guns. Gadgets have sensors too. Some of them are used to detect the touch of your fingers or the orientation of your smartphones whenever you shake or rotate them. Even a simple digital thermometer and weighing scale have sensors too. Most of the machines and devices found in the hospital are using sensors. Some of them are the stethoscope and the ultrasound scanner. Why do sensors are important? Sensors are everywhere. Most of the malls, comfort rooms, amusement parks, gadgets, hospitals, and even at homes are using devices that have sensors. Sensors have countless applications. Without them, there would be no automation. mBot sensors. mBot has two sensors, the ultrasonic and the line follower sensor. Ultrasonic sensor can be used to measure distance or obstacle detector from 3 cm to 4 meters. Line follower sensor is designed for the robot to follow a black line and a white background or vice versa. In this lesson we discuss, sensor is a device that detects its environment and responds to it. Sensors can be found everywhere, in the malls, comfort rooms, hospitals, amusement parks, and even at homes. mBot has two sensors. The ultrasonic sensor that can be used to detect distance and the line follower sensor to detect black and white objects. End of the lesson. Lesson 9. Line tracing. At the end of this lesson, the student should be able to identify the connection port between line follower and controller board, and can create a program to make the mBot follow the line. Before we proceed to this lesson, the student should have already taken the lesson on different types of sensor ports, and can define the line follower sensor. Let's have a quick review of the past lesson. The introduction to sensors. Line follower sensor is designed for the robot to follow a black line and a white background, or vice versa. Sensor ports have indicator numbers. It is used to indicate which sensor will use to track a line. Sensor 1 is located at the left of the line follower sensor, while sensor 2 is located on the right. A drop-down menu of line follower block is used to identify the ports and where the program will execute. Port 1 is for sensor port 1, 2 is for sensor port 2, 3 is for sensor port 3, and 4 is for sensor port 4. Number 0 is equal to 2 sensors. It detects black line. Number 1 is equal to left sensor. It detects black while the other sensor detects white line. Number 2 is equal to right sensor. It detects black while left detects white line. Number 3 is the 2 sensors. It detects white line. Let's create a program for line tracing. First, we need the mBot program block to upload directly to the mCore. Wait until button is pressed blocks are for the program execute when the button is pressed, followed by the forever block to make the program runs repeatedly. Inside the forever block is the if-then block. It is where the conditions are inserted. In this program, if the line follower port 2 is equal to 0, the robot will run forward at a maximum speed. The value 0 means both sensor 1 and sensor 2 is on the black line. Here's an example of an mBot line tracing. Reminder: the line follower sensor can read any light color objects like yellow, pink, and light blue as white. Any dark color objects like brown, maroon, and dark violet will be considered as black. Let's have a quick review. What is the offset value if both sensors are on the black line? If your answer is 0, then you are correct. What is the offset value if the right sensor is on the white line and the left sensor is on the black line? If your answer is 1, then you are correct. What is the offset value if the right sensor is on the white line and the left sensor is on the black line? If your answer is 2, then you are correct. In this lesson, we discuss line follower can be connected in any sensor ports, sensor connection and program compatibility, and if-then controls is used for conditional execution. Line sensor's value of detecting black or white line is 0 to 3 only. The line follower module has 2 sensors. End of the lesson. Lesson 10. Ultrasonic sensor. At the end of this lesson, the student should be able to calibrate the ultrasonic sensor and create a program for the robot to avoid objects, walls, and etc. Before we proceed to this lesson, the student should have already taken the lesson on Introduction to Sensors. Students can identify an ultrasonic sensor and give its function. Let's have a quick review of the past lesson. Sensor is a device used to detect the environment and respond to it. mBot has 2 sensors, the ultrasonic and the line tracing sensor. Before we program the sensor, we need to calibrate it first. It is important for us to know if the sensors are working properly and if the sensors is sending the right sensor values. This program is used to calibrate ultrasonic sensor. When you press the green flag, the panda will say the distance between the ultrasonic sensor and object. Here is an example program for ultrasonic sensor. Every time the sensor detects an object between 0 to 9 centimeters, red LED will turn on. If the object is 10 centimeters away or farther, the green LED will turn on. Here is an example program for obstacle avoidance. The program will start and wait for 5 seconds after you press the button. Inside the forever block, every time the sensor detects an object between 0 to 9 cm, the robot will turn right. If the object is 10 cm away or farther, the robot will run forward. This is sample video for obstacle avoidance. This is an example scripts for obstacle